All right, folks, this is it. Volume and unit price. You got to consider both. They both factor into the net cost of something. Now, what does it have to do with mass timber? I'm in a grocery store. Well, if you're interested, stick around. That's what we're going to talk about today. Well, hey folks, welcome back to another Timber Talk Tuesday. I'm Ricky McLain with WoodWorks. Cost of mass timber buildings is by far one of the most common questions that comes up. Many people are attracted to the use of mass timber as a building material, as a structural material, as the finished exposed structure in a building. But of course, it only makes sense if financially it pencils out. So that then begs the question, how much does a mass timber building cost? Well, this video is an attempt to explain some of the design and construction decisions that you can have an influence on that help minimize the cost of mass timber buildings. This video is not going to give you a hard cost in dollars per square foot of a mass timber project, because the answer, as you may not like it, but it does depend. It depends greatly. And one of the things that really heavily influences how cost efficient, or just in general, how much does a mass timber building cost, is how efficient the design decisions are in utilizing that mass timber. So as you saw in the introduction to this video, I'm going to focus on two distinct areas of emphasizing how we can make design decisions that influence the cost of a building. First of those is the volume. How much volume of timber are you required to purchase for a project, and what design decisions can you make that minimize that required volume? And the second is unit price. What are the specific things that you can do in design that can help optimize the mass timber products and help lower the unit price? All right, first taking a look at volume. Now, a lot of people recognize that in order to design a mass timber building efficiently, you want to utilize the mass timber in the most efficient ways in terms of how far it can span and the size of the members that you're using. So that's kind of the fundamental understanding of volume. But I do think it needs to go beyond that. Now, starting out by taking a look at what volume of timber does your project need. Now, I harp on this all the time in these videos, and I'm going to do it again today. And I'm going to start by looking at construction type, really optimizing the particular project that you're working on for the best construction type according to the International Building Code. The reason that this is so important is because if you can dial into a specific construction type that has maybe a lesser fire resistance rating requirement than other construction types while still meeting the requirements of the International Building Code for the occupancy and size of the project that you're working on, those lesser fire resistance rating requirements are going to inherently require smaller sized timber members in most cases. Obviously, smaller sized timber members are going to reduce the overall volume of timber needed on a project. Now, to present one example of how this decision of construction type has such a big impact on the volume and therefore the cost of a mass timber package, I'm going to show you this project. This is from the University of Denver Burwell Center for Career Achievement. This is a project that PCL Construction did, and these numbers that I'm sharing here are from them, so I appreciate their input here. This is a 3-story project, and initially it was evaluated with an assembly space on the 3rd floor. Now, under the IBC, a building with an assembly space on the 3rd floor that has some options for construction type that allow the use of mass timber would have required a construction type 3A. Now, construction type 3A generally requires a 1-hour fire resistance rating for all structural elements, floor construction, beams, columns, floor slabs. So their initial design looked at a 5-ply CLT panel with beams and columns and connections sized to meet a 1-hour fire resistance rating. However, what they found during design was that by taking that assembly space from the 3rd floor, placing it on the 1st floor, now their options for construction type expanded, and they could use construction type 3B. Now, type 3B does not require a fire resistance rating for beams, columns, floor slabs for this particular occupancy of building, so therefore they could drop their 5-ply panel down to a 3-ply panel. The beams and columns were not required to be sized for an hour, nor were the connections of those members. And in this specific example, that one design decision and programmatic layout change, resulting in that construction type changed, was a $12 per square foot savings, again, due to the reduction in timber volume. Now, one of the metrics that I like to use when determining how efficient is a project in utilizing mass timber, specifically the volume, is what I call timber use intensity. Now, timber use intensity is simply taking a ratio, looking at what is the total volume of timber that you're using over a given area. So you can do this based on one individual column bay. You can do this over an entire floor plate, but basically add up the total cubic footage of timber in that area, divided by the area itself, the square footage. And that gives you a ratio, say 0.7 cubic feet of timber per square foot of building. Again, refer to this as the timber use intensity. I did a whole video talking about ways to look at different calculations associated with this, and you can check that out in the upper right-hand corner. So that timber use intensity is one of the metrics that we can use to determine, is this the most efficient use of timber, the volume of timber required in this project. Again, run several different scenarios and see which one of those scenarios for your given project, for your given construction type, for your given fire resistance ratings, results in the lowest TUI, or the lowest ratio of timber use per square foot. Now, one of the things I think is really important when it comes to mass timber and mass timber design is thinking beyond just the construction drawings that you're working on, thinking specifically about what's going to take place at the job site. Specifically, think about things like, how many pick points does this layout of timber require versus that layout of timber? Another metric that you can use here is the number of pick points per 1,000 square feet of building. And if you're not familiar with the term pick points, it's simply referring to individual pieces of timber that are being picked off of a truck or a staging area and erected into place. So each beam is one pick point, each panel is one pick point, each column is one pick point. So by running the timber in one direction versus another, one grid scenario versus another, you can start to see maybe one layout has an X number of pick points per 1,000 square feet. Another layout has X plus 3 pick points per 1,000 square feet. The third thing that I would say on this topic is really to do your best in design, integrating the mechanical, electrical, plumbing, and fire protection services in a manner that minimizes penetrations through the timber, and I would say specifically through the timber beams, the glulam beams. By minimizing the number of penetrations, we do two things. First of all, we minimize the structural impact that those penetrations have. Right? A penetration through a beam is going to have an impact on the structural integrity of that beam. And if the impact on the structural integrity of that beam is large enough, it could require the beam itself to get larger to accommodate the penetration. That goes then obviously back to our TUI. We've bumped up the volume of timber, so our TUI has gotten higher, which means efficiency has gotten lower. So we can also look at the number of penetrations in terms of a per 1,000 square feet basis, again, to give us a metric. It's not to say that a certain number is the target goal, but it just allows you to evaluate several different designs to see, is one more efficient than another in terms of these number of penetrations through the timber members, and how can that impact the cost of the mass timber package. The second thing that we can gain by minimizing the number of penetrations is minimizing the work that's required to be done on the coordination side as well as in the fabrication facility of the mass timber. And this really leads into our second main topic of the day, which is unit price. When looking at the unit price of a mass timber package, we need to understand that a lot of this comes from the work that we're requiring a mass timber manufacturer to do in their facility. The more connections that they have to fabricate, the more work in terms of flipping panels over to coat both sides of a mass timber panel, to do CNC work on mass timber beams and columns. Those are all things that add cost, add unit cost, right? Without changing the volume of timber, they're adding unit cost to the mass timber package. Now, certainly in some cases, this is going to be inevitable, right? We have to have connections between beams and columns. So a lot of this may be inevitable, but there may be ways to design it more efficiently so that that fabrication work by the mass timber manufacturer or even potentially a secondary fabricator is minimized. And again, the point of all of this is to simplify the design and draw down that unit cost. And this really speaks to the importance of understanding the manufacturer that you're working with, what is efficient for them to fabricate, what may be less efficient for them to fabricate, and dial in the specifics of your project per their capabilities. And then lastly, an example where the volume and unit cost really tie in together is something like panel products where maybe we're using laminations of varying thicknesses. For example, some manufacturers produce a 3-ply panel or a 5-ply panel where perhaps the strong axis or major axis laminations are of a certain thickness, maybe they're 1 3/8, and then the weak axis or minor axis laminations are a thinner lamination, a thinner layup. So that can be more efficient in terms of material use, right? That draws down the volume of timber used, but it may be a little bit less efficient for them to fabricate because they're pulling from 2 different lamination piles in order to create that panel. Now, you're still going to get a benefit in terms of the overall cost when compared to, say, the full panel with all laminations of the same thickness, because you are reducing the volume, but it may not be a linear relationship. So understanding those nuances of fabrication and manufacturing costs and how they lead into unit cost is important in terms of how you go about making those design decisions. So I hope some of these tips have been helpful to you in evaluating, is your design for your mass timber project the most efficient that it can be? Maybe my 4 takeaways I would give you at the end of this video is: number 1, fine tune the construction type to make sure it's really dialed in to the specific needs of your project. Number 2, think through the construction logistics. It's more than just what's happening on the drawings. You have to think through what's happening on the job site. Number 3 is understand and work within the capabilities of the manufacturer that is supplying the mass timber for your project. And number 4 is to minimize the penetrations through the timber members to the maximum extent that's possible. Well, that's it for today's video. I thank you so much for making it to the end, and until next time, we'll see you later.